Hello, so today we are going to do this problem, which is part of Leetcode daily challenge, number of ways of cutting a pizza. So what this problem says is we get a rectangular pizza that is represented by rows, by a matrix, rows by column, of course. And this matrix has A, which will represent an apple, and has a dot, which will represent an empty cell, and we get also an integer k. And what we are doing in this problem is cutting the pizza into k pieces using k-1 cuts, right? Because to cut into 3 pieces, you just need two cuts, right? So that's sort of the idea here. Now, for each cut, you have only 2 possibilities for the directions. You can either do it vertically or horizontally in this rectangular pizza. It's a little bit weird that the pizza is rectangular, but yeah, that's the problem. Then you choose. Also weird that it's a pizza that has apples. They should have just chosen cake, but yeah, I digress. So you can cut either vertically or horizontally. Then you choose a cut position at the cell boundary and cut the pizza into 2 pieces, right? So if you cut it vertically here, the problem is to tells us to give the left part of the pizza to a person. So and we are left with the remaining parts to divide further into further cuts until we do all k-1 cuts. Now, if you cut horizontally, then you give the upper parts of the pizza to a person, right? And then we give the last piece, of course, to the last person. Now, the problem asks us to determine the number of ways we can cut the pizza such that each piece that we give to each person has at least 1 apple, right? We can't give one person a piece that doesn't have apples on it, which means basically we can't cut in a way where the part we are removing doesn't contain an apple, right? So that's the first, that's the constraint, and what we want is the number of different ways we can cut it. So that's the idea here. Now, of course, here they are asking us to use modulo. We can use that. But if we take a look at the first example here, we get a 3x3 rectangular pizza like this. And so one way we can divide it is cut here horizontally. And so we give the first person this portion here, right? And we are left with the rest. And so for the rest, we can cut it, for example, vertically. We'll give that person this. So you can see here, it has an apple. Here it has an apple. So we are still within our constraint. And now we did k here is equal to 3, which means we need to do only 2 cuts. And so the last person gets this piece, and we did only 2 cuts. And we cut it into 3 pieces, and we did 2 cuts, right? So within our boundaries. The other option, again, cut horizontally, but when we cut vertically, cut from this side. So the second person get a different slice, and the last person gets this slice. And still each one of them has an apple, so should be good. The last different way we can do this is cut vertically first instead of horizontally, right? So this person gets an apple, 2 apples here, so we are within our constraint. And then we cut again vertically, right? So the second person gets this, and then the last person gets this, and each has an apple on it, okay? So these are the only 3 ways where we have valid configurations. Notice we can't actually do this cut, right? Because if we do this cut, then this person gets the apples, but what's remaining doesn't contain apples, so the last person doesn't get an apple, so that's not a valid way to cut the pizza. Okay, so that's the explanation of the problem. Now, if we look at the constraint, we have only up to 50. So 50 by 50 is the max, and k is only up to 10. So this tells us that the constraints are not too big. So some sort of a brute force solution should work. Yeah, so that's pretty much the explanation of the problem. Now let's see how we can solve it. Okay, so how do we tackle this? So first there are a couple of observations we can just think about while playing with the problem, right? So the first one is that the problem says, so here I'm going to be representing A with apple with A, and this is the pizza. So the problem says that if we cut horizontally, let's say this is the pizza, and we cut horizontally, so something like this, then we give the person this top piece, and then the remaining is the bottom piece, right? And if we cut vertically, so something like this, right? Then we give the person, we give it the left part, and what's remaining is the right portion. So this is what's remaining here, this is what's remaining here. Okay, so what's common between these two? You may notice, right? What's common is that the bottom right portion stays the same, right? So this is basically the number of rows minus 1, columns minus 1. This is the coordinate of this one. And the usual way to define a rectangle in a matrix, or a portion of a matrix, you can define it by just the top left corner, right? By your top left corner, and then your bottom right corner, right? So here, for what's left for us to divide further, right? So we will need to divide this one further, right? So what's left is going to be always still having this as the bottom right corner, but the top left corner changes. So for example, in this case, let's say we cut here, and let's call this maybe I, right? Because it's a row. So let's call this row just the one before, the last one in the cut, let's call it I. So then here it's going to, and this is of course going to be what row? It's going to be row I plus 1, because the next one, and the column is going to be column 0 in this case, right? And here, let's call this cut at J, then this is J plus 1 here. So J plus 1, and what's the row? Row is row 0, right? Okay. But here 0, right? Once we, this here just represents the column from the top left from the before recursion call, because remember, it's not always going to be 0. Once we cut vertically, it changes, right? It's going to be J plus 1. So this is just the previous top left column. So let's say if the top left is always, so that we are not stuck with 0, let's define it as R1C1, the top left. So that it works when we recurse. So here this is going to be C1, right? This is because the same column. And let's call it here R1. So this is going to be R1 J plus 1. Okay. And so this one stays fixed, but this one also we can obtain, right? So that's the first observation here. Now, the second thing to notice is that we don't know which one is better. We don't know if it's better to cut horizontally. We don't know if it's better to cut vertically. We don't know at which position it's better to cut, right? We don't know. And so when we don't know, let's just try all of them. And like intuitively, it doesn't seem like there is an easy way to find the optimal way to cut. And so since we don't know, and the constraint of the problem says the rows and columns are up to 50 and K is up to 10, which is not a big number. So if we can try all of them, right? And so let's just try all of them, which means basically each time we'll try to cut horizontally on all possible places. And then we will try to cut vertically also on all possible places. What does that mean? So that means, let's say if this is like from 0 to 5, so that means we'll try to cut at row 0 here, which means basically we give the first row to the person, and then we have the remaining part. And then if that doesn't work, we try to cut at 1, we try to cut at 2, all the way until the last place we can cut, which is R minus 2, right? Because we have to leave this one to the last person. Yeah. And then same thing vertically, we do the same thing. We cut at 0, we cut at 1, at 2, all the way till the end. And so we try all of them. And then if we are able to do all the required cuts, which are K minus 1 cuts, right? So that's the first constraint. So what are other constraints that we need for our cuts? So the first one is that we need to do K minus 1 cuts. The second one is that each cut, right, needs to contain that we give to a person needs to contain an A, which is an apple basically. So we'll try all of them, but we won't try if when we cut we won't give the other person an A. So if we are not able to give that person an A, we won't cut. So we'll just do this, but we'll try all of them. Okay, so that's the sort of a couple of observations there that will help us solve it. Now the second thing to ask is, we'll try all of them. We'll recurse, of course. What would be the state of our recursion? What do we need to pass to our recursion? Well, the only thing we need is, since this one is fixed, the bottom right corner is fixed, we just need to pass each time the top left corner. That's the only thing we need to pass, right? And so the state of our function is going to be something like, let's call it maybe count ways. It's going to be just the coordinates of the top left, which are, so top left coordinates here, which are going to be R1 and C1. And of course, the remaining number of cuts we need to do, right? Because we need to know, we can't cut more than k minus 1. And so we need to know when we reach 0. And that will be, by the way, our base case, right? So that's the first thing. Now, what is our base case? We definitely know that if cuts is equal to 0, we should stop, right? Because we already did all the cuts. The other case is if the remaining portion, let's say we did cut somewhere here and the remaining portion doesn't contain an A. Well, there is no use in proceeding because we won't be able to do any valid cut, right? And so that means basically if we end up with what's left doesn't contain an A, that means we can't, this is not a valid way to cut the pizza. So we stop and we return 0 because it's not a valid way. And so what we can do here is just to check if, right, if not apple in pizza, the remaining pizza, right, we should return 0, right? Now, how do we tell this function what section of the pizza to look at? Well, we know the top left is this one, is R1 and C1, so we'll give it the top left corner. And then we need to give it also the bottom right corner. So we need to give it where to start and where to stop. And as we said, the bottom right is this one. And so we just give it that. Okay? So return 0. Now, if we get here in this case now, that means there is an apple because we didn't enter this if loop. So we can just return 1 because that means there is a remaining apple in the last cut, and since we reached here, it means previous cuts, all of them had an apple on them. And so this means this is a valid cut, so we return 1. All right? Okay, so now these are our base cases. We should be good. Now the second step we need to do, we need to have the count here that counts the number of ways from this state to cut pizza in different ways. And now we try all of them. So here we try to cut horizontally, and then we try to cut vertically. And then we have another way where we cut vertically, right? Okay, so now for cutting horizontally, well, we just try all possibilities, right? So we just have I, which is the row we will cut at. And we need to try all of them. But when we are here, by try all of them here, so on this portion, by try all of them, it means starting from here, right? And then for the horizontal part, when we are recursing on this portion, right, trying all of them means starting from here, right? Not from the beginning, starting from just the submatrix that we have. We try to cut here, we try to cut here, we try to cut here, right? So that's the idea here. And so that means we start from only the top left, right, row, which is R1, but it needs to be +1 because we can't, right here, right, when we are left with this submatrix or whatever you want to call it, we can't cut actually here, right? We have to cut because we need to give that person something, right? Something that contains an apple, right? And so that's where we here R1 +1, and we need to, when do we need to stop? Well, we need to try all of them, all the possible cuts, all the way to the end here. And so that's why we need to do here up to R minus R, right? Cool. Okay, so up to R. And now for each of them, we just try, which means we add it to count the number of ways, and then we try recurse, which is count of ways. Now, what is the new coordinates for the top left? Well, that's exactly what we said here. The new coordinates are I +1. Sorry, not I +1 if we had So we have two choices. If we want I to be the one we give to the other person, we can do R like this. But if it's want to be the one we use ours, the one we left, then this is going to be I, right? So let's say if I is actually here, this is going to be I, right? And here, if J is actually here, then this is going to be J, right? It depends on where you want to represent I and J. Both work the same way, right? And so here, that means it's I. And as we said, the column is going to be C1, stays the same, so it's C1. And then we just did a cut, so this cuts now, it's cuts -1. Now there is one condition, which is we can't cut if, well, we can't cut here. We can't cut here, right, if this portion doesn't contain an A, because that means we'll give someone a piece of the pizza that doesn't contain an apple, but that violates our constraint here. So we have to check, make sure that what we are giving to that person contains an apple, which means we have to check that this portion here contains an apple. And so how do we do that? Well, we already have our function apple in pizza, and so let's just call that function. And so what we want to do here is only if the portion we are giving, so the top one contains an apple. So apple in pizza for what is the top left coordinates? Well, the top left coordinate is just this portion here, which is the submatrix R1 and C1. And what are the bottom left, right? So in this case, let's do a new one. So we are here, R1, C1, and let's say we cut here. What is so this is the top left, it's R1, C1. What's the bottom left? Let's say we cut here, and this is I, so this is where we cut, so starting from I here, and so this is I -1. And so what this says, and this is column -1, and this is R -1. And so what this tells us is that this is basically just I -1, C -1, right? And so that's the last piece here. So I -1, C -1. Basically, we are making sure that what we are giving to the person, this portion here, actually contains an A. Because if it doesn't contain an A, so if we had that here, then this is not a valid cut. We can't do this cut. We have to cut to here maybe, right? And so we have to check that it contains an A. So that's what we are doing here. And then now for the vertically, it's the same concept, just we need to do it in the vertical order. And so instead of I, here we are going to do for J. So it's going to be for J in the range of, now what's this one? It's just C1 plus 1, the same way we did horizontally, we try this one, vertically we try this one, right? And so that starts from C1 plus 1, of course, because we do it here, right? And so that's exactly what we are going to do here. So C plus 1, and then we stop the same way, we stop on the last column. With Python, this is going to be C -1. And then we do the same check we did here, right? So we want to check if apple in pizza, right? We want to check. Now, what should we pass here? So this is now let's try it with this one. So let's just delete this and see what it looks like. So this is going to be R1, C1, right? And this is R -1, C -1. So this is C -1, and this is R -1. And so when we cut vertically, let's say, for example, here, let's call this J at this position, then this is J -1. Okay? So how do we represent this portion here? Well, it's R1, C1, that's the top left. What's the bottom right? The bottom right has the row R -1 and has the column J -1, right? Just before the cut. So it's, then let's just write that exactly like that. So that's going to be starting, top left is R1, C1, but the bottom right is where we cut. So it's J -1, R -1, and J -1, right? That's exactly what we said here. It's R -1 and J -1. And so that's if this is the case, now we can do the proceed to the cut and do the cut and proceed to recurse on the remaining portion of the pizza. And so we do count plus count ways. Now what do we recurse on? Again, similarly here, we need to recurse on this remaining portion. We need to recurse on this remaining portion. Now, how do we define this remaining portion? We know it's bottom right. What is its top left? Well, its top left is just, we know the column is G. What's the row? Well, row is just the same row as before, so R1, right? And so it's just going to be R1G, right? And then the bottom right is the same, right? So that's why we said here R1G, and the bottom right is R minus 1, C minus 1. Okay, and that's pretty much it. And then at the end for this function call, we want to return the overall count that we just calculated with all possibilities. And remember here, we return 1 only if we get down to, we do all the cuts, and all the cuts contained an apple. And so here we return that count. Okay, and so we just tried all of them, and we respected the conditions here, the constraint that we have, which is we need to do exactly k minus 1 cuts, right? And then we need each cut to give the person A. And then the rest is just manipulating coordinates, right? Now, the only thing we didn't do is checking if apple in pizza, but this is easy because we have the top left, we have the bottom right, so we can just traverse the entire submatrix and check if any of the values is A, we return true. And if we do the entire submatrix and we didn't find any A values, we return false, right? And that should be pretty easy to do. Yeah, so that's pretty much the idea here. Now let's implement it and make sure it passes. Okay, so let's see how we can, let's write the implementation. So the first thing we need is the function that we are recursing on. So the top left corner and then the number of cuts remaining. And we need our base cases, which are if there are no apples in this portion, there is no use in trying to cut it because it's not valid. We return 0. Otherwise, if the cuts equal to 0, that means the remaining pizza has an apple and we did all the cuts, so we return 1. So this is a valid way to cut, so we return 1 because it's one way to cut. Otherwise, we proceed and we try all the possibilities. So we try to cut horizontally and we try to cut vertically. Okay, we already saw this in the overview, so we shouldn't spend a lot of time on it. So cutting horizontally is just going to be going through all the possible eyes we can cut at, and then we check if the pizza we are given to that person, to the person which is the top, from the top, contains an apple. If it does, then we recurse on the remaining portion of the pizza, right? And then we cut vertically as well. And the explanation of these values is already in the overview, so we don't need to repeat it. And then we cut vertically again. We try all the possible cuts vertically, so we just go through the columns we can cut at. And we do the same thing. We check if the portion which is the left side of the cut we are given to the person is going to have an apple. If it does, we are good. We can recurse on the right portion and try to get the number of cuts we need, right? And then at the end, we just return count, right? Yeah, and these values are all explained in the overview in the earlier section, okay? And now we just need to call our recursive function here and launch it, right? So the first thing is we also need to define these rows and columns, which just represents the number of rows and number of columns. And so that's just going to be the number of rows and number of columns. And the problem also says to use a mod, right? You can choose to use it here, right? But the values are so small that we can just use it at the end. And so I'll just, yeah, if you want to use it here, you can just do something like count plus, and then each time make sure you mod, right? So that's what we are, let's do it. So, and just make sure you mod each time like this. And that should be it. And here we should mod as well. And we mod at the end. And that should be it, except, so here we we call our recursion, we start from the initial top left, which is 0, 0. And then the bottom right is, of course, it's just row -1, columns -1. It's just the last cell. And the problem says we get k, we want to cut into k pieces, but the number of cuts we need to make are just k -1. So that's why we pass k -1 here. Now the only thing left to do is to define this apple in subsize, in sub pizza. So let's just define it. This one should be straightforward. We get the top left corner, we get the bottom right corner. And so we can just go through the rows and columns in these boundaries, right? So that should be just 2 for loops for the coordinates I and j. So the I is going to be from R1, right, from the boundary rows beginning to the end of the end row, and same thing for the column. And then we check if pizza, I'm going to call it P instead of pizza, just to be easier to write. Right, so just P like that. So if this cell Pij is A, that means there is an A in this sub pizza, right? So we just return true. And then if we try all of them and it's not there, we can return false. And that's pretty much it. So very brute forcey, but it should be fine with the constraint we have. Let's see there is an indent problem here. Yeah, because of this, okay. So it passes these, but one thing to note is that because of we try all of them, we will have some repetitive states, and that if we don't memorize, this will get called multiple times for the same input and it get executed again. And so in Python, we can use cache. If you want to do a hash map, you can also use it. I will leave that exercise to you. You can just use these inputs as the key and check if it's in your hash map. Use the cache. If it's not, just return. If it's not, just continue your calculation. Do the calculation, right? So pretty straightforward there. We don't need to go through it. So let's run this. Let's submit, and you can see it passes. One thing to note is that this is not optimal, right? Because each time we are checking, so you can actually optimize this using a prefix sum on the pizza matrix, where basically you do a pre-processing step where you mark A, the values of A as 1, right? And then you do the prefix sum normally. That way it's really easy to check boundaries that have a top left and the bottom right corner, both top left and bottom right corner. You can use this to check if the submatrix contains sum is bigger than 0. If it's bigger than 0, that means there is an A. Because if it didn't contain A, the sum would be 0, right? Because A would represent 1, right? So that's one way you can optimize this. I won't write it here to make the video short, but you can try to write it. So that's pretty much it for this problem. Please like and subscribe, and see you in the next one. Bye.